Hi, I'm Craig Meyerhopper. I'm Vice President of Business Development at Alphen High Performance Products. We're here in the cutting room at our manufacturing facility in Niwot, Colorado. This is where we take all of our basic raw material framing materials, which are fiberglass, and we stock them in the lengths down there. We have them painted here once they come down from the manufacturer. And then each one of those are going to be cut to a specific size on every custom order. We have a pretty intense dust collection system here because, as you can imagine, when you cut fiberglass, there's a lot of particles that are put into the air.
Oh, sure.
So as we cut, all of that fiberglass dust is going up through this dust collection system and out into the dust hopper in the other room. And so it's very, very clean in this room, even though we get a lot of fiberglass dust particles.
Yeah, the air is very clean. There's nothing on the floor.
Yep.
It's completely dust-free.
Yeah.
It's pretty amazing.
It works. So it's a little bit of a makes it a barrier to entry almost into the fiberglass world, trying to figure out how to manage that dust problem, the fiberglass dust problem when you're cutting a material like fiberglass. So, but we've got it down. So this is, like I said, this is the cut room. So we have miter saws in here, various different saws for cutting different profiles at different angles. So all he's doing is taking down the raw material length, and then he's going to measure it and cut it to size. Again, every order that we manufacture here is custom. So we don't stock any material, any particular size. Everything is cut for a specific order.
Okay, so he's working on a custom order right now.
He is. He's working on cutting a piece.
And what kind of machine is this?
Well, it's a saw, obviously.
It's a saw. It's like a very high-tech saw.
Yep, yep.
Let me get in as close as I can.
Specifically for cutting fiberglass. And as you can see, when he makes that cut, you don't see any dust.
Right, I see that. That is
He has
cool.
a cut list of every size and every angle that he has to cut to. And there are two different saws that he'll use here depending on the profile of the material and the angle he's got to use.
Okay, and this is how he makes all the frames.
Yep.
So we'll watch him do this one more time. Yeah, this does not look like your dad's woodshed
No,
with
it
dust
doesn't.
flying everywhere. This is pretty controlled environment. Let's see him do one more.
He's going to be in here. This is where we drill into the individual pieces for the hardware to go in.
Okay.
And it's a measured process because if we have something go wrong in the field and a sash goes bad, we can replace the sash, and we know because we're specific with our measurements of where all the hardware goes.
Ah.
When we take the sash back out to the field, the hardware is going to fit when we replace that sash because it's always going to be in the same place.
Ah, I see. That's
So it's
interesting.
all pre-measured.
Okay, Craig, so this is where they build the boxes?
This is where they build the boxes. So they're taking the cut frame material that we just saw, and they're coming in here. Now we have, if you look over there, the insulation. So we take the fiberglass framing material, and this is a good example right here. So we've got our profile, and then the insulation material goes inside of the fiberglass frame.
Ah.
So you have a double insulated frame.
Okay.
With fiberglass on the outside and then our foam insulation on the inside.
Okay. And what type of foam is that? Do you know?
I don't want to say because I don't want to give you the wrong information, but we'll ask Tom about it
Okay.
because it is key to the insulating factor of the window.
Okay. And so these ladies are drilling these pieces together.
Exactly. So they're putting the pieces together and drilling them together. And then in the corners, where we can't get that foam insulation all the way to the corner, we fill that with a gunshot insulation into the corners.
Okay, so it's like a liquid insulation that just supplements.
Exactly.
Okay.
So we know then we have the entire cavity filled with insulation,
Okay.
which most companies, window companies, don't do. You have those corners get left open. It's a unique thing that we do by filling those corners, we know we have a complete airtight seal all the way around the insulated part of the window.
Okay.
So we talked about the fiber reinforced PVC product that we're coming out with. And this is a 4-point welder that we purchased from a local company. It was a vinyl window manufacturer. And we'll be using this when we start to manufacture in-house our fiber reinforced PVC product, which will be sometime within the next 30 to 60 days.
Okay.
So we're just getting this piece of machinery up now. We've ordered some additional parts and circuit boards that we need to make it run. But this little section will be just dedicated to putting together, cutting and putting together the frames of that vinyl PVC product.
Okay.
We're taking the frames that we built over here, frames and fasteners. They come over to this side, and this is where we actually put the windows together. Put the
Okay.
framing members together with operable parts. And then they also start to get the window ready for packaging. And you can see some of that wood starting to go in for packaging.
Okay.
This is an example of what our glass units look like when they come up from the glass shop down in Denver.
Okay.
And I talked to you a little bit about the racks that we have to be able to transfer things around safely.
Yeah, there's grooves there to protect
To hold it in place.
and hold them in place. Okay.
Yep. And we've actually custom built all these. So they fit exactly our glass depth.
And then back here you have some of the finished product.
Those are going to be some finished product when we get. So you'll notice what look like Mylar balloons. What these are used for, because we're making our windows at elevation.
Oh, yeah,
So
that's true.
many times we're going up to the mountains or we're going down to sea level.
Ah.
So we'll get back to where we insert an inert gas into the cavity of the window. We're either going to use argon or krypton. So that gas tends to move around a lot when we're going up or down in elevation at a significant footage. So these balloons will either fill up or let out as we're going to elevation, and when we get to the site, then we leave those on for maybe 72 hours to allow that gas to stabilize before we then cut and crimp and then tuck it beneath the glazing stuff. So I was showing you this hole up here. So when we put the suspended film on down at the glass shop, we make a little hole in the corner of each unit that has the suspended film. It's kind of hard to get up in there. But what that does is when we do the gas fill with either argon or krypton, it allows that gas to move back and forth between the chambers because it wants to move. So you have to give it a doorway to travel through, essentially. And so you have to have a little hole in there so that the gas can move back and forth between the chambers. So this is where we're putting that glass, the insulated glass unit, or IGU, into the frame. You can see around the corners, it's just being pushed right into that fiberglass frame. And then they'll take what's called a glazing stop and then insert that on all 4 sides. And this is an example of what that looks like after the glazing stop has been put into the frame. And that's what holds the glass unit into the frame. So we're doing some final packaging here with the wood and providing handles so that we have a way to handle the material safely. You can see that the wood is completely on the outside of the frame. So once we shrink wrap that, then you have complete protection of the glass and the frame for shipping.
So this is delivered to the customer just like this with the
Just
shrink
like
wrapping.
this. Yep.
And then it's pulled out of the wooden frame and placed into position.
Inserted into the building, the structure.
Okay. And of course, all different sizes and shapes.
Yep, this is a big one here.
Okay, so this is where the final packaging happens.
Yep, packaging line is right there. It just spins around and puts the shrink wrap. So we've got our wood all around the exterior of the frame. We have a corner protector, cardboard corner protector. We have our handles for safe lifting, and then the shrink wrap on the end. And then every one of our windows gets an NFRC label, which talks about the performance, U value, R value, solar heat gain coefficient, light transmission. It's all there on the NFRC label.
Okay, the
of every one of
NFRC
them.
is kind of the
National Fenestration Ratings Council.
okay. And this is important for window units. Why?
Yeah, well, because they are the ones who certify the performance
Okay.
of your window.
Okay. Okay, cool. So these are now ready to ship.
So once the glass units come up from our facility down in Denver, the film on the inside is very loose. It's not tight. We take those, we put them on these racks, and it goes inside of this big oven. We shut the doors. We bake them for about 2 hours. During that baking process, that film then tightens, and the tension becomes almost like a timpani. And so the suspended film in the center is not touching any glass. It's just suspended and tight across the middle. And that gives essentially a third or even a fourth pane of glass. But it's a film, so it doesn't weigh anything. So you can actually get a triple or quad pane window performance with the weight of a dual pane window.
And then what's happening back here?
So this is where we do the gas fill.
Okay.
And we have another oven, it's on the other side of it. Back here is where we're going to do our gas fill. And we do our inspection of all the units after they come out of the oven, and then do the gas fill with those units right there. Again, either argon or krypton, and then they're inserted into a hole that you can see it right here.
Ah, yes.
So that's where our gas is going to go into the chambers.
And what's the difference between krypton and argon?
Our krypton is a much more insulating gas than argon is, and obviously a much more expensive gas to purchase for us as well. So our higher end window uses krypton, and we get a much more higher insulating value out of that window than we do out of a window with argon. But argon is still a very good gas to use for an insulating value.
Does the customer choose this, or?
Nope, it's our window line. So different series of windows that we have. As we move up the food chain, we're going to move into the krypton gas as we get into the higher level series. So this just is an example of the pultrusion of our fiberglass lineals. So it starts out in these fiber strands, and then as it's pulled through the machine and heated and into a form, you end up with a profile on the other side. That all starts from the strands. So these are just corner samples. This is our 725 series, more of a slim line and a krypton gas fill, and then our 525S series, which is a little bit of a wider glass pocket.
So this kind of shows up close what we've been talking about out on the manufacturing
all the
floor.
way through. So you see the insulation within the profile, and then you can, it might be hard to make out on camera, but you can see the suspended film on the inside of the 2 panes of glass, and then the metal spacer.
Hi, I'm Robert Bush. I'm the Maintenance and Facilities Manager for Alpen Performance Products. What happens here is we make IGs. And it's all
What is an IG?
IG is insulated glass.
Insulated glass, okay.
And what happens here is this is the raw glass comes in from the glass mill.
Okay, and these are sheets of glass, and you have a really cool mural on the wall. But, okay, so these are sheets of glass, and they're different variations of thickness?
Thickness and coatings on the glass. Some are low E glass, some are low E.
Okay. And so these are cut to fit the specifications of the windows and doors that are being made at the facility. Okay. All right. So the main operation here is to
cut glass and assemble an IG, which is insulated glass.
Okay.
So it'll start here with, we're going to cut a certain size glass per order, you know, and it's done here on this table.
Okay.
And this is a manual table. We're going to be getting an automated table.
Okay. So the glass is just literally laying on the table.
Yeah.
And then what?
An operator uses this tool, places it on the glass, cuts it.
That cuts it?
This tip cuts it.
Oh, wait, let's see. Okay. Interesting. All right. And it's cut to...
Once it's cut, they snap it and break it in half. Okay, these spacers come in different sizes and grades of material.
Okay.
This is a high cube, but we also have a stainless steel spacer.
Okay. You have lots of different ones stacked over here.
And what happens here is...
This is a bender, you said.
Yeah, this machine bends it into a frame, and then it also drills a hole for gas fill.
Okay. Yeah, and we talked about that. We talked about the hole that's drilled for the gas fill, and this is kind of the key to the insulation process.
This is
right?
yeah.
It basically is what holds the suspended film between the two glass units. You have the film suspended. The spacers allow that film to pinch and hold.
Okay.
These are stainless steel spacers that are filled with desiccant. They're putting this machine.
What is
there.
desiccant?
Desiccant absorbs moisture. So
Okay.
anytime the window starts sweating, it'll absorb moisture.
Oh, okay.
These holes in the frame are perforated, and that's where moisture will be absorbed.
Okay.
So they put the frame in here, hit the pedal, it'll drill 2 holes, fill the spacer with desiccant, and then seal the holes
Okay.
with PIB. Edge deletion machine, what it does is,
What's it called?
an edge deletion machine.
Okay.
What it does is it removes the low E coating that's on the glass. And the reason for that is better adhesion for the PIB, which is the material that seals the gas in.
Okay. And so this machine does that.
Yeah.
Okay. And the glass lays on top of these rollers.
Yep, and there's a
Okay.
grinding wheel behind
Okay.
that cover.
Okay. All right.
And the grinding wheel removes any
Ah,
coating.
cool.
This is our washer. What it does is after the glass is edge deleted,
Uh-huh.
we clean the glass. And there's 4 tanks. One is a pre-wash, one is a wash, one is a first rinse and second rinse.
Okay.
The wash tank's heated to 140 degrees. The first rinse uses regular water, but the second rinse uses DI water. DI and RO water.
Okay.
So it's really, really clean.
Okay. That's good.
And then at the end of it are some air knives that blow it dry.
Okay. Now, is it your responsibility to keep these machines running?
Yes.
Okay, so tell me like a typical problem that you might have with a machine like this, and how do you fix it?
Typical problem, I just had a heater go out, so I had to replace the heater.
Okay. And so,
that's
do you have
one problem.
regular checks or?
Yeah, we have PMs on the equipment.
Okay.
Yeah, thermal imaging and stuff like that. you know,
Okay.
to pick up any hot spots
All right. And you handle the maintenance on all the machines
and
here?
all the equipment, yes.
Okay, good, good. And you have a little bit of help?
Yeah, I do have a helper now.
Okay,
Yeah.
good,
Uh-huh.
good. And then the guys in at the other facility said they sometimes can step in and.
Yeah, they give me a
Help it.
hand too sometimes.
Okay, good, good. So once it goes through this machine over here.
Right, so we put the bead of PIB on both sides of the spacer.
Okay.
We now have a piece of glass. The PIB is on both sides. You can see it on this side. And then the spacer is set down on top of the first piece of glass. This PIB that you see here is going to seal to the film that's going to lay over the top of that. And we can
Okay.
see what that looks like on the other side.
Okay.
So the rolls, so there's 3 different rolls of film on here, depending on what we're trying to do. Are we trying to bring the solar heat gain in to the structure, or are we trying to reflect it back away primarily? But these are low emissivity, I can never say the word. Low E. We
Low
just call it
E,
low
okay.
Film, coated film with low E coatings on it.
Okay. Okay, so these are 2 pieces that already have the film on, and they're
Right.
going to be sandwiched together.
Right, so we'll put another spacer on top,
Uh-huh.
and then another piece of glass on top of that.
Okay.
So we're going to go glass, spacer, film, spacer, glass.
Okay.
Or
And then it goes through
the
this
press.
machine,
The
through the
press.
press, and that's how they all stick
It
together.
pushes
Yes.
it all
It
together to
squeezes
make
it all.
sure
Okay.
you have adhesion all the way around that seal.
Okay. All right.
And then we actually, so
And it comes out the other side ready to go?
Almost ready.
almost.
Is there's another process?
Yes.
Okay. And what is that?
The other process is polyurethane pump.
Okay.
What this does is it dispenses our secondary seal,
Oh, okay. Here we go.
and it's a 2-part. It's a base and a catalyst. So it's mixed at a 12% ratio, and it gets dispensed. And what they do is they use the gun and they fill in the gap here with our secondary seal, and that helps the whole unit stay together. It also, the primary reason for that is it holds our film, so when it's heated and shrunk, it doesn't pull. Well, it pulls, but it doesn't move. It holds it in place. Kind of holds the whole structure of the window in place.
Okay, so this is a finished piece. It's already been, it's got the secondary seal on it.
Yep, all the way around the perimeter.
All the way around. And then,
Except
you know,
where the gas fill hole is.
oh, that's right, okay.
Yep.
Alright. Okay, nice.
You can see up there on the very top corner of that.
Yes,
That's where
that
the gas
space,
fill.
yeah. Okay.
Oh, it's up there. You can see where that sealant stops
Yes.
right in here. That's where the gas fill is.
That's where the gas fill is. Okay.
Now remember I told you when you see it come off the line, it almost looks a little wrinkly.
Yeah,
And you can see the film in there.
right.
That's before we bake it.
Okay, so the baking,
When it bakes, it shrinks, but this sealant holds the perimeter in place. So as it shrinks, that's when it tightens.
This machine requires the most maintenance. It's the polyurethane pump. And
Okay.
the reason for that is it's because of the material.
uh-huh.
It's real abrasive, so it wears out cylinders and it clogs screens, and yeah, it requires constant maintenance. Also, it's really sensitive to air, so if you get any air in the lines,
Ah.
it'll really give you problems.
Yeah.
So
So what kind of preventive maintenance?
on this machine, well, what we do is we check to make sure all the packings are tight on the cylinders and all the oil cups are full of oil. We also stir the material because it gets separated over time, so we mix it to make sure it's at the right consistency, along with filter changes. And there's a desiccant dryer on here that we have to replace every time it turns colors from pink or from blue to pink. When it turns pink, we have to replace it.
Okay. So how many units would you say go through this facility in a day?
About
Yeah.
100.
About 100?
About
Okay.
100 units.
And then you ship them
depending
on-
on size.
Okay.
Small units, they could produce a lot more than large ones.
Right. Okay.
So I'd say 75 to 100 on average.
Okay.